Hello.
Deepak sir, good morning. Sir, good morning.
Good morning, ma'am. So, are we waiting for some more time?
Yes, sir. Another 5 minutes.
Okay, okay. Can you give me the option to share?
Yes, sir.
So we'll wait for another 1 or 2 minutes.
Yes, sir.
Okay. Meanwhile, that we can start this session today. Now, in the chat box, you can just write how many of you are familiar with R? Because what I would like to do today is I would like to conduct the entire session using a case wherein we will be using to a larger extent R and SPSS and then Excel, and then we'll combine all of that together. Okay. So I think so we can go ahead, right?
Yes, sir. Sir, we will start, I think.
Yes, ma'am. Let's start.
Yes, sir, you can start.
Okay. Okay. Good morning, everyone. Welcome you all to the second day of the MDP on multivariate analysis and research. And what I would like to do today is many of the time when we have plenty of data which is there, where the data which is collected, how will we be able to go ahead with analyzing that data, and specifically considering that we have the data which we should be able to reduce, and then we should be able to use it for various regression as well as various classification based methods. So before we jump into any methodology, we all know that first one is data processing plays a very important role. Once you have processed the data, then you will be going ahead with the data visualization. You will be trying to understand what the data is, what the data is telling you. And then once you have analyzed it, you will be going for, if you have got a lot of questions, you or a lot of variables which are there, you will be going for dimension reduction. Once you have done dimension reduction, you will be going for various other statistical methods. So the procedure that will be followed today is I'll be discussing a simple case. Now, this is the case which is given in the book on research methodology by Deepak Chawla. Okay. Now, if you look at this case, I have just made some modifications to this case, wherein this case is easily understandable by all, wherein all we are trying to do is we are trying to understand the investor behavior. And here, instead of 80 respondents, I have made some modifications to the data, wherein we will have closer to like 500 odd respondents who are there. So you have got 500 odd respondents, and the respondents were asked questions with respect to which place they come from. And on a scale of 1 to 100, what do they feel their risk averseness is? Risk averseness is referring to how much is the capability of them taking the risk, and do they actually do any research, and what is their current salary, everything else which is there. So we will be mainly looking at these aspects which are there. So if this is the case, I would like to show you the data before we can jump into the analysis. So this is the data which is there. Okay. And this is, consider that this is the investors. So these are the investors who are there. And this is the place, this is the risk averseness. Here we have got whether they will be able to do any research or not on a scale of 0 to 100. Then the salary that they are getting, this is in 10,000s. And then when they started investing, okay, so when did they actually start investing? And then we have got various other measures which are there in order to understand their behavior. And once we have understood their behavior, it is possible for us to ask some more questions on tell me what are the investment strategies that you adopt, whether you invest in mutual funds, whether you invest in shares, in fixed deposits, everything else. And by having this data, it will be much useful. So what I have done later on is I have transferred the data into SPSS. Now in SPSS, all I did require is with respect to their responses with key aspects, and these key aspects which were there is on a scale of 1 to 5. If I'm going for the Likert scale, I wanted their responses on the risk averseness, returns, insurance covers, tax rebate, maturity, credibility, easy accessibility. And if there are any missing values which are there, it has the values which are there has been designated as 999. So you will be able to notice that on one hand, we have got some demographic information regarding the investors. And on the other hand, we have got some brief information on what do they feel when it comes to certain measures which are there. So if this is the case, if I am looking at this data which is there, and these are the various responses, I should be able to look at this data, try to understand this data firsthand, and then I should be able to go ahead with further analysis or analysis of the data. So if I feel that these variables which have been covered, where we have X, totally 7 variables which are there, if it is possible for us to reduce the dimensions of these variables and then go ahead, how should we be able to proceed further? So for that reason, what I felt is instead of we discussing about this case and then going into various statistical analysis as well as in terms of techniques, it is very important for us to understand the data that you have got from the respondents, and do you feel that this is credible enough for you to go ahead with the research? So if this is the case, what I felt is we, to a certain extent, we have been using Excel as well as in terms of SPSS to a certain extent. All that was discussed in the last class is you have got data view, you have got variable view. In the variable view, you will be able to designate the data, whether and designate what kind of measurement is it. And then what we majority of the time we try to do is we go to analyze, and then we will be able to look at some of these statistical measures which are there. So last class, what we did is we directly jumped into hypothesis testing, where we looked into univariate and to larger extent with respect to ANOVA and its various variations which are there. Now today what we'll be discussing is we will be mainly concentrating on understanding the data. So majority of the time what we will be doing is we will be covering in terms of the descriptive statistics, and within these descriptive statistics we will be looking at frequencies, descriptives, and then we know that the graph which is there plays a very important role, wherein what kind of graph should I be able to use, and once I have understood the entire data, then it is possible for us to go further into various multivariate analytic techniques, which are mainly I will be covering today is unstructured or unsupervised learning methods which are there. So what I'll do today is I'll directly go into R programming. So this is the console where I will be able to type in the codes and get the output also. And what I want to do is I want to go ahead with the script wherein I will be writing the codes, and so that this can also be used by you all when you are analyzing the data. And what I have done is this Excel data which I have got. Okay, so this is the Excel data that I have got. What I have done is since I want to copy this data and use that in R programming, I have converted that into CSV file. Okay, so I have converted that into CSV file and I'll be using this data. Now, what I wanted to do is, since many of you might be familiar with R, but just I'll spend another 20-25 minutes, which should be sufficient enough for you to understand the R interface which is there and to understand what the codes are. And then I will be able to get the data, and then we'll be able to understand this data much better. So when it comes to R programming, specifically when we are talking about R programming, this is what was used by statisticians as well as mathematicians a lot, because this involves less amount of coding. Also, it is easily understandable, and now we also have Python. So what I thought is we can go ahead with the R interface only. Now, like we discussed in SPSS, that whenever you copy any data and when you want to designate what kind of variable is it, we will be able to just check first one, whether it is a qualitative data or whether it is a quantitative data. Depending upon what kind of measure is it, we will be able to decide what kind of statistical measure that we should be able to go for. So similarly, when we are looking at specifically R programming, what we mainly try to look at is we try to look at what kind of data that it can handle. So if I am talking about the type of, you will be able to notice that you get this has a float value or double. So if I have got type 4.3, I've got double, and if I want to consider this as an integer, I will be able to consider it as L. And it is R is also able to understand the various text values or the character values. So if I'm able to have the text within the quotes, then you will be able to understand that this is nothing but the character. And the other type of data that it can understand is you have got logical values of the Boolean values which are there, and then we do have the complex values which are there, 3 plus. Okay, so we have got complex numbers also which can be analyzed, and we always look at what is referred to as typecasting. So if I have certain amount of data and I would like to convert that into a specific format which is there, I can go for as dot integer. So if I have got a text value, okay, and if I want to convert that into a number, I can go for typecasting. Or if I have got a number and I want to convert that into a text, I can use as dot character. And when it comes to basically various mathematical functions that can be done, so we will be able to, and for understanding and for running it, what we will be doing is we will be using control plus R function in order to run these codes also. So various mathematical functions can be done. Now, if it is multiplication or if it is an exponential function. Okay. Now, what is important for us is when it comes to assigning value to the variables which are there. So if I want to assign values to the variables, we will be able to use less than or hash symbol. Okay, this is referred to as an assignment operator. So if I want to assign a value, we will be able to assign the value to a specific variable and then use this for various mathematical functions later on. So I think so you have got the crux of it. So if I want to use R programming, what I am trying to do is I know what kind of data it can handle. And if it comes to assigning some values to the variable, so that these values which are there or variables which are there can be used across. So if I have got these, what I want to mainly look at is I want to look at assigning, and specifically when it comes to the naming conventions, this can handle in terms of underscore, like with respect to other softwares also. So dot operator, which is not understandable in Python. So you have got but you cannot assign a variable, or you cannot name a variable with a number, starting with a number. So that is the first thing that we should be able to understand or remember. So if we have this, what I want to look at is, whenever we study or whenever we look at R, we mainly look at the vectors. Okay, so everything that is there in R is built on the logic of a vector. So if I have got a variable, and if I want to assign several values to the variable, okay, so we will be able to use this combine function. This is also referred to as a concatenate function, which is there. Similarly, this vector of numbers or one-dimensional array of numbers which are there can also be created using the colon functions, or we can go with what is referred to as a sequence, wherein I specifically explicitly referring to a sequence of numbers which is separated by certain value. Okay, so and then I can have the repeat functions also, wherein I'm looking at some value to be repeated some number of times. So if I say 2 number of times, it will be repeated twice. Okay, so if I have got this vector of numbers, I can have the vector of text values also. For example, hello class, and I can have the vector of the Boolean values also, which are there. So we have got, these are nothing but vectors. So what is very, very important is, whenever we are working in research, we all know that we would have collected the data, and these data which is there is going to be discrete in nature. For example, if I have collected the data on gender, and if I say male, female, okay, so if I have got the values which are discrete in nature, and if I look at it, what R will be able to understand is, these are just in terms of the text values. But I know that this is referring to the levels which are there. So this is a factor. So yesterday we understood that there might be independent variables which are discrete in nature, and might have several levels which are there. So if I want to designate that, I will be able to use a function called as factor, and then I will be able to say there is definitely in terms of an order which is there. So if I say this is nothing but in terms of order, it will be able to understand that the text values are discrete in nature, and it has got 2 levels. And if I come to know that these are having 2 levels, so if I go for a table function, you will be able to notice that it understands that there are 2 female and there are 4 males. And then it is possible for us to come up with the bar plot, wherein I will be able to say how many male are there, how many female are there, and you will be able to notice whenever we come across research and whenever we are collecting some data, we have certain descriptive statistics, we have some questions which are nominal based. And if we want to analyze any data, all we can do is we can say what is the frequency, what is in terms of the percentage. And if we want to add some more graphics to it, we can, these numbers which are there, if you want to convert that into vertical form. So last, if you want to have the color, so we can add some color to it. We can say some red or blue. So you will be able to notice that it is possible for us to, and if I say horizontal equals to true, we can convert this. If I want the names to be given, I can say one refers to male and another refers to female. So it is possible for us to make these corrections which are there and customize some of these aspects. And that's why most of them are going towards these open source softwares which are there. So if I have got, if I know how to actually look at this data and convert these data and understand that there are some data which are completely numeric in nature, some are discrete in nature, some are nothing but ordinal type of data. So if I say this is strongly agree, then you have got neutral, then strongly disagree, you have got disagree, and then I can repeat these aspects which are there. Now, if I have it, if I want to consider that there is some order, or this is nothing but an ordinal data, what we can designate this as? We can designate this as, this is nothing but the factor, and this factor is nothing but it is ordered. So I'll say ordered equals to true. And then I will be able to designate that this is nothing but the ordinal data. So I will be able to say what is the way in which we will be able to designate in terms of the levels which are there. So if I say strongly disagree, disagree, neutral, agree, and strongly agree. And then if I'm able to now say, if I'm able to now look at in terms of the data. So here, levels. Now, if I look at this data, you will be able to notice that this is able to now understand that this is nothing but it is a discrete data, but this discrete data which is there is having some levels which are there. Now, once we look at this data also, now if I come up with some random number with a mean of 25, standard deviation of 10, and then n number is 100, for example. We have got these random numbers which are there. And if I want to look at the histogram, okay, so it is possible for us to understand this data right away, or if I want to understand the distribution of this data, it is possible for us to briefly understand what this data is. Are there any outliers? So what we first try to do is, we have collected some data and we will be able to first look at the summary of the data, and then so we also have, so if this is the case, because since I have got a lesser time, what I'm trying to do is I'm trying to just give in terms of the snippets which are there. So all we have is R is able to understand the data, and depending upon what the data is, we can appropriately understand the distribution, or conduct or come up with various plots which are there. Now, what is very important is the data structures, because since we will be handling a lot of data, we have collected the responses of 500 respondents who are there across various variables, and we should be able to copy that entire data which is there and then use it for further analysis. So how can we actually capture all these data? So when it comes to our, we have some data structures which are there. One is nothing but in terms of it, when we talk about a vector, it is a one-dimensional array of objects. When we talk about a two-dimensional, it is nothing but in terms of a matrix. So if I have a variable called as mat, and if I want to have a matrix, so we will be able to use a function called as matrix. So matrix consisting of some numbers, for example, I will say 1 to 12. The number of rows that I want to have is 6, for example, and I want it to be arranged row wise. So now if I go for mat, you will be able to notice that you have got all these numbers, or all these numbers have now been arranged in rows as well as columns. So in 2 dimension, that is nothing but a matrix. And if I want to retrieve any information, I can go for subsetting functions, wherein depending upon what I have as before as well as after comma. So before comma refers to the rows, after comma refers to in terms of the columns which are there. So if I designate this as 1 comma leave space, it will be able to understand that I am referring to the first column or first row across all the columns which are there. Similarly, if I want to subset and then say comma, then 2. Now, what I'm saying is I want all the values which are there across the second column, across all the rows which are there. And if I want to go for any specific value, the intersection of specific row as well as column, I can go with this. Now, if I use minus symbol, it designates that leaving this row, the first row, give me all the rows across all the columns. So if I go for it, you will be able to notice here that it will not consider the first row, and it will be able to consider all the values which belong to the rest of the rows. And what we do is we can go for matrix multiplication also, wherein if I use percentage star percentage and the T mat, T here refers to transpose function. So if I'm going for transpose and if I'm going for the matrix multiplication also, it is possible for us to do these very easily. So you have first structure is nothing but matrix. We have got array. Then we have got the list data structure, wherein in the list, it is possible for me to capture various data types. So if I have got 1 to 100, if I have got another column or in terms of another structure wherein I have got text values, and then C is nothing but if I have the Boolean values. So if I have here in list, okay, C, concatenate. So if I'm going for list 1, you will be able to notice that it is possible for me to capture the different types of variables within this data structure called as list. And then if I go for, if I want to retrieve any information with respect to any of these components, it is possible for me to use $sign and retrieve this information. Now, what is important for today's session is one of the data structure which is referred to as a data frame, and we know that we have been using the same thing in Excel also. So if I'm going for data, and then if I say data.frame, and then if I say how we have the data in Excel is column wise, these are referred to as the features, and that is what we discussed also in the last class. We have got the features. So if I have got first one, for example, serial number, I've got 4 students who are there. And then if I say name of the students who are there is Suresh. If I have it, you will be able to notice that now if I go for this data, this will be able to look like as we are doing the same thing in Excel, wherein the data is arranged in rows and columns, where the columns designate some specific values which are there. It designates only serial number. The name column which is there considers only in terms of the text value, and it refers only in terms of the names. And if I have, for example, I have got the marks of the students, and this marks is scored by these 6 students who are there. And if I want to add this, I can go for cbind function. And then if I consider marks, you will be able to notice that it is possible for me to add as many columns as possible. So what is important for us is in this session is, if I have got data and if I want to analyze this data in R to start with for my introductory research. So what I will be able to do is I can go for copying this data, okay, into if I have saved this data as a CSV format, I'll be going for what is called as read.csv. And since I don't want to go for a path, I'll just go for choosing where this file is. And I will say the header, the first row which is there is having the names of these columns which are there. And now if I go for finding out where that data is, so I have got this as factor analysis, because the data that I will be using it later for dimension reduction purposes only. So if I have captured this data, you will be able to notice if I go to view data, what I have here is I have got the investor names which are there. So here investor names I am asking in terms of risk averseness, their research, salary, investing, and I have asked certain questions which are there with respect to various parameters. And if I'm specifically looking at, since the data is there, I should be able to first understand this data and then proceed further. So if this is the case, if I go for, here we have viewed the data. What I want is I should be able to get some summary of the data. So depending upon what R has understood, these each and every column to be either they are qualitative variables or whether they are quantitative variables. If they are quantitative variables, it will be able to give you the summary statistics in the form of minimum, median, everything else. And if it considers it to be qualitative in nature, it will be able to give the values. So here there are some misinterpretations which happens because it is all data in as well as the data out. So what we have is the name of these investors. For example, we have got the place from where they come from, the risk averseness, the research, the salary, investing. So here we will be able to notice that the place which is there is going to be a factor because there are some distinct values which are there. So if I take the file itself, and if we look at the data which is there, and if I can look at filter, you will be able to notice that the investors who are there are from specific places, and these are distinct in nature. So all I want to do is I want to be able to consider that these are nothing but these are distinct values which are there. So if that is the case, I should be able to tell R that these are distinct values. So here what we will first do is, if I look at the structure of the data, you will be able to notice that it recognizes the places which are there just as text values, but doesn't consider that these are nothing but the distinct values which are there. Similarly, when it comes to investing, these are the years which are there. So instead of it considering this as numbers and calculating minimum, maximum for it, I want it to be considered as factors. And similarly, since most of the responses which has been asked on certain scales, okay, these are what is your risk averseness. When you go for investing, will you look at the maturity values or maturity time? So if that is the case, we had asked it on a Likert scale on 1 to 5, and I want it to be also recognized as in terms of the factors itself. So first and foremost, what we tend to do is when we look at these structure of the data, we want to make some changes to this data. So if that is the case, first and foremost, what I would like to do is this place which is there, I would like to convert or consider that this is nothing but this is a distinct value or it is a nominal data. So if I have taken this in SPSS, you will be able to notice that if there are any distinct values which are there, I should be able to consider them as in terms of the nominal data, and then I should be able to proceed further. So here I will have data dollar. First, what I'll do is I'll go to the names, and I would like to change the name so that it is very convenient, because here I have got salary 0.00. I don't want that. So what I'll do is I'll change the names which are there. So first one, I'll say name of the investor. The second one is the place, then hoursness. So what do they feel? And on a scale of 1 to 100, how do they rate in terms of the research which is there? Would they do research? If they do plenty of research, then the numbers will be much higher. And similarly, we have got salary. Then we have got, this is the year from which they have started investing. And then we have got, we'll keep these values which are there as it is. So you have got X1, X2, X3. I did not wanted to just run through these codes today. So I just wanted to type so that you will be able to understand what's happening. So here, if I am able to consider the names, so here, so if I have the names, now if I go for the first 6 rows, if I want to look at the first 6 rows, you will be able to notice that the names have been changed, and it is possible for me to look at whether the data has been copied correctly or not. So once I have this, and now what I want to do is, if I go for once again summary of the data and structure of the data, the place which is there, I want to convert that into a factor. So if I go for data dollar place, I want it to be converted into, I want the R to understand that these are nothing but nominal values which are there. So if I consider data dollar place, and this is nothing but distinct values. And now if I, similarly, what I want is the year which is there. I want the year also to be considered as a factor. So data dollar year ordered is also false. Now, if I look at the summary of the data and the structure of the data, you will be able to see that the place which is there is now considered as a nominal data with 7 levels, and you have got year also as nominal data. And similarly, if you consider that, okay, these are the various values which have been given. Okay, 1, 2, 3, 4, 5, and this is what kind of data? This is nothing but it is an ordinal data. So if you have given Likert scale, and then if it is considered as an ordinal data, then what we would like to do is we would like to have these observations which are there to be converted into factors. So data dollar x1, I want ordered to be true, but it has got some levels. Now, what are these? Because I want it to understand that there are some alter. So if I say, okay, so if I consider this and now go for the structure of the data, now you will be able to notice that this x1 which is there is now considered as an ordinal data, and it is having 5 levels, and then we have got 1, 2, 3, 4, 5. So 1 here refers to strongly disagree, disagree, neutral. Okay, so if that is the case, I can just copy the same thing and repeat this process which is there for rest other variables also. So this is x2, and so on so forth. Okay, so So this is for the third variable, this is for fourth. And we can use the functions also in order to loop this and do it much faster. So you have got third, fourth, fifth, sixth, and as well as seventh. So if I now go for the structure of the data, you will be able to notice that this is nothing but it is an ordinal data. Now, once we have understood that this is the data, and once we have processed this data, okay, there are various other processing also, but for now, you have processed this data which is there. Now, once I have processed this data, now what I will like to do is, many of us will like to first spend a lot of time on understanding our data. So for that reason, if I am able to use the ggplot, which you are all familiar with, if you are going for the ggplot library also, I have already downloaded it. So if I'm going for ggplot, what I would like to now understand is, I would like to understand the relationship that exists among these variables that has been captured, and I would like to know more about this data. So if this is the case, when we go for ggplot also, what we try to do is we try to go with several layers which are there. Now what we are doing with respect to ggplot is, first we have got the data, and this data which is there, we would like to map it, and this is always referred to as aesthetics. And then we would like to say what these points or these data which is there will have what shape, whether it is point, line. So this is always referred to as geometry. And then if you want to add some statistics to it, we will be able to add some statistics layer. And above the statistics layer which is there, if you want to understand across the years, or if I want to get multiple plots, we will be able to go for a layer called as facets, and then we will be able to label the data. And once we have labeled the data, then it is possible for us to add some themes to it. So these are the various layers that we always follow when it comes to the ggplot function. So what I have is, first I have got the data. So I have got the first one, I have got the data. Now if I have got the data, so I'll go for ggplot. The name that I have, okay, all the rest other, the entire data set which is there is given in the variable called as data. And since I want to add or plot this data or map this data, I'll be going for aesthetics, and here x equals to, if I say I want to understand hoursness as well as the risk. Okay, so because since I'm talking about the investors, I would like to know their hoursness, and then deciding upon it, I will come to know more about whether they would like to go into investing in stocks, whether they will have more affinity to invest in mutual funds or not. So if I go for x equals to, if I consider this as hours, and then if I would consider research which is there. Okay, so here you will be able to notice that all we get is an empty plot. Since I want to decide the data that I have considered, what kind of structure that it will be able to have. So if I go for what is called as G, on geom point, you will be able to notice that I have got on the x-axis the hoursness of the investors, and then I have got the research, the way that they will be able to conduct research before they will be able to go for investing. So we will be able to notice that as they become more and more risk takers, they would like to do more and more research. So before they go for any investing. But if I would like to understand more about this data, what I can add is I can add the color to it. So if I say I would like to come up with the color, wherein the color is based upon the place, for example. So if I take the place and I am able to look at if there are where all the investors are, and specifically if I want to look at where these investors are, and if I have collected the data across various places, what kind of investors are across various places. So if I go for within the place and then say I want to look specifically into Bangalore, okay, and then you will be able to notice that the false true here refers to all these values which are there. All the true values are indicating that these are the respondents who were from Bangalore. And then I will be able to understand what kind of investors, or when I have got the data, these data which has been obtained represents what kind of investors, and this will be much helpful for me in the further research also. So you have got this data which is there. Now what I would like to do is, instead of me typing this many times, all I can do is I can go for some base layers. So if I have a object, and then if I'm going for ggplot data, if I'm adding in terms of an aesthetics layer, and here I will say hours y equals to research. Okay, so I can just have this layer, and then on top of it, I can go with the point, or in terms of designating that this is nothing but the ggplot data. Okay, so and if I want to make any changes to it, we will be going for what is called as mapping. So here, aesthetic, here I can mention the color. So you will be able to notice that it specifically designates these observations which have been obtained, and the salary which is there also plays a very important role. So if I would like to say that the size here refers to the salary of the investors, so you will be able to notice here that I have got not only the place, I am able to understand the salary, and then if I say specifically with respect to Bangalore investors, and then if I'm looking at the salary, everything else, you will be able to understand what kind of investors are in majority of these places. And this is the first aspect that we will be trying to understand in our research before we can go with lot of statistical methods which are there. Now, when it comes to, and what I'll do is I'll just briefly show in terms of the important aspects which are there. So if I go for a base layer, and then if I consider ggplot data, and here if I'm saying I would like to take just one variable, that is nothing but hours. And since I have got one numerical or quantitative variable, and if I want to look at the histogram of it, okay. So here I have got the histogram, and this is able to, I have got around 500 responses which is there, and if I'm looking at the dimension of the data, you have got 562 observations across 13 variables which are there. So if I have got this histogram, and if I specifically say, if I say the aesthetic layer, the color which is there, fill is nothing but, if I take once again the structure, so that I will come to know in terms of the names. So I have got here the salary as well as research, and I have got the place also. So if I say fill according to the place where the investors belong to, you will be able to notice that all it does now is it will be able to say where based upon the awareness of the investors and based upon where they are from, this will be able to give clear indications, okay, as to where what kind of investors are. And if I can go for coloring this data, this will be able to give me the awareness of the investors across in terms of the places. But if it is possible for me to add some multi-plots, okay, so if I want to come up with some facet grids, and then if I say based upon when they started investing, so if I am looking at it, you will now be able to notice that I have got not only the analysis with respect to awareness and what kind of investors are. I'm able to understand when they started investing and what kind of investors are from my data set also. Now, if I have got this is the data that I have got. Now, what we are trying to do is we are trying to look at the responses also on various scales that we had. Tax rebate or maturity time, everything else. And if I have got these variables which are there like X1, okay, this is nothing but in terms of your ordinal data that we had. So if I am looking at the places, okay, and then if I'm looking at the data or the kind of responses that they had given, was the first question which was there is if I'm looking at the first question, the score on the risk awareness. Second one is score on returns. If every question which is there is asked on an ordinal data, all we are trying to do is we are trying to picturize it. And this is able to give us much more better inference rather than what we try to do is whenever we go for SPSS, we have got this data. We go for analyze, we'll be able to go for descriptive statistics, we go for frequencies, we take the score on risk awareness. Here in the statistics, we will be able to select, okay, so we can have bar charts. Then if I go for okay, and then if I'm able to look at the output, this is the output that we'll be able to get. And these are the plots that we'll be able to understand, we'll be able to get. Now, these plots, though it is much relevant, you will be able to notice it doesn't give you much more information. Rather, if you are able to go for ggplot, and now it is possible for you to understand the place from which one comes from, the awareness also, as well as in terms of the on a scale that is on a risk awareness which is there, what were the various responses. So you will be able to notice majority of the responses which are there are here with respect to 4 as well as in terms of 5. So same aspect, if I want to further elaborate it and then say facet grid, let this be based upon. So now if I have it, you will now be able to notice the kind of chart here. X1 is here, the scales. Yeah, one. Now notice what has happened. We are not only able to get the data year-wise, but we are able to get the data across in terms of the places, but with respect to the first question that we had asked, that is on risk awareness. So we are able to understand this data which is there in a much more easier way. And this would definitely help us before you start your research, because before you go for various statistical tools as well as in terms of techniques, what we would like to understand is we would like to get more insights. And if I have this diagram which is there, I can write several research papers on it, because it is clearly able to indicate that what kind of data that I have got, and since I have collected it across years, how over a period of time the investing strategies has changed or investor behavior has changed according to the risk awareness also. So you will be able to notice that this is able to give you the transition which has happened with respect to investor perception, all these aspects. So if this is the case, when I do consider this case and assuming that we have understood enough with respect to the values which have been collected, and you will be able to notice that all you have to do is you have to go on changing x1 x2 everything else, and you will be able to understand with respect to certain specific questions that you have asked, what were the kind of responses that you got across the investors who have been rated based upon their averseness also, or you can consider in terms of the research, as the research capability of the investors increased, would they like to do more research before they can go for investing? So specifically when we are talking about IPO issues, when we are talking about book building process, everything else, so here it is able to give us better insights. Now, once we have collected this data, what we would like to do is we would like to say that this data that we have collected might be too bigger for me. I would like to further reduce the dimensions of it. So if I have got 7 observations or 7 variables which are there, I would like to further reduce it. So what we do is, in any kind of research, what we have is we have got plenty of data and we would like to reduce the dimensions of the data without compromising on the percentage of the variation which is explained. So if this is the case, the same case study, if I'm able to consider it, so what we have is, this is the data, this has been copied and pasted in SPSS. And what I would like to now do is, I would like to go for factor analysis, which is nothing but in terms of, I would like to go for dimension reduction method. Now, what are the various steps that I will be able to follow? Is SPSS does it very, very easily, but what is the problem is, one is not able to understand what this data is and how will you be able to interpret this data, and how are these results actually obtained. Because if you are able to understand specifically with respect to PCA, if you are able to understand how did you actually arrive at all these tables, everything else, you will be able to find that it is much more easier for you to look at further various other statistical methods also. So if I go to analyze, if I'm going for dimension reduction, and if I go for factor analysis, and in the factor analysis, if I'm able to consider the data that I have collected, and if I go for descriptives, univariate, and I will explain this KMO-Bartlett test of sphericity which is there. And then we have got the extraction. We are going with the principal component analysis. And why PCA? We have what is called as the scree plot. We want the eigenvalues which are there to be greater than 1. And I'll try to explain it more better when we go with each and every output. We will be using in terms of the Varimax method. And then here the scores which are there, we will try to use regression, save the variables as regression, displace factor score coefficient matrix which is there. And then we have got options. And then if I say okay. Now what is very important is, when I look at the output, we have got several tables which is there, okay, and all we are trying to do is, we are saying that when I started my research, I had got plenty of variables. From the research also, I know that there are some underlying constructs which are there that I would like to recognize, and if that is the case, first and foremost thing is, I will be able to go for some principal component analysis or factor analysis, and I would like to further use various other statistical tools and techniques later on once I have done the factor analysis. So if this is the case, what is important is, in SPSS, these are the various steps which are there that we did. What is very important is, why was this PCA or factor analysis conducted? How were you able to get these outputs which are there? And how can you use this for various other multivariate analytic techniques, which we might be dependency based techniques which are there. Within dependency based techniques, you are concentrating mainly on the regression based methods or in terms of classification based methods. So all we are trying to talk about today is interdependency, wherein we are considering that we have collected the variables, but I cannot identify which is dependent variable and which is independent variable. So what I'm trying to do is I'm trying to reduce the dimensions of this data. I've just taken 7 variables. So I want, if I have got like 50 questions, or if I had got 50 variables or 60 variables, I would like to reduce the dimensions of this data and use it for further analysis. So when you go for factor analysis, there are some important conditions which are there, which needs to be looked at in factor analysis. And once you have looked at these conditions, only you can go further. So it is very important that first we consider what these conditions are. So the first condition is the significance of the correlation matrix, which is there, is tested using Bartlett test of sphericity. And what we assume here is the null hypothesis is the correlation matrix which is there is insignificant in nature. And what do you mean by insignificant is the correlation matrix is an identity matrix, and where diagonal is an identity matrix, and the null hypothesis, alternative hypothesis is correlation matrix is significant. So what do we mean by it is, I have copied the same data which is there in Excel. Okay. So if I have got this data, all I'm trying to do is I'm trying to obtain the correlation matrix. Now, according to the Bartlett test of sphericity, or according to the factor analysis, first and foremost thing, what we want is we want to ensure that there is high correlation among the variables that we have considered. Okay, so if it is an identity matrix, that means all the diagonal values are 1, and then off diagonal values are all 0. So if it is an identity matrix, it is not possible for us to go ahead with the factor analysis. That is the first thing that we should be able to understand. So if I am able to do the correlation, so I have got this data which is there. If I go to data analysis, if I go to correlation, okay, and if I'm taking the input range, and then the columns are designating in terms of the various variables, and then if I go to the output range, if I get the output here, now you will be able to notice that what we are now trying to understand is this correlation matrix which we have obtained. Is this correlation matrix an identity matrix or not? And that is first understood by going for the first one, which is nothing but the Bartlett test of sphericity. Now, according to the Bartlett test of sphericity, all we are trying to understand is it significant or not? So you will be able to notice here that according to the Bartlett test of sphericity, the significance value we will be considering, we will be rejecting the null hypothesis if it is less than 0.05, and we will be able to notice that yes, of course, it is not an identity matrix. And similarly, we will be able to look at the reliability, and you will be able to look at in terms of whether the data that is there collected is adequate enough or not, and we will be able to go for the KMO, measure of sample adequacy. And for this, you will be able to notice that once we have it, this depends upon the literature, and if the value which is there is greater than 0.5, according to majority of the literature, it is 0.6 or 0.65, then we will be able to consider that this is sufficient enough for us to go for the factor analysis. And what this KMO tries to look at is it tries to compare, you will be able to notice it compares the magnitude of the observed correlation coefficients which are there with the magnitude of the partial correlation coefficients. And then the small value of the KMO which is there shows that the correlation between variables cannot be explained. And for that reason, what we do is most of the PhD research, we will try to ensure that this is more than 0.6 for 0.65. So the first and foremost aspect that we will try to look at is the first condition is the Bartlett, we look at in terms of the Bartlett test of sphericity, and then we look at in terms of the KMO statistics. So once we have looked at it, then what we do is we follow certain important steps in the factor analysis. And there are basically two steps. One is we look at the extraction of factors. That means if you have got these results which are there, when you ran through the factor analysis, you were able to understand that you have got two factors. Okay, and if you look at in terms of the output which is there, factor analysis is able to say that all these 7 questions which are there can be reduced into 2 factors, and these factors are nothing but variates, which is nothing but linear combination of the variables. And you will be able to notice that these 7 variables can be reduced into 2 factors, and the first factor which is able to explain 29% of the variation, the second factor which is there is able to explain 22% of the variation. That means the cumulative, both of them together are able to explain 51% of the variation. So 7 variables can be reduced to 2 factors. Now, how did we get these 2 factors? How did we get in terms of these 2 values with respect to these 2 factors is very, very important before you jump into various other methods also. So if this is the case, first we'll try to look at in terms of the extraction of the factors, and then we'll try to look at how to interpret this data. So first and foremost thing is we will be able to look at the extraction of the factors. Now, what we have to decide is how many factors are to be extracted from a given set of data. And we know that these factors which are there are nothing but the variates, which are nothing but linear combination of the variables, wherein you will be able to notice that these X values which are there, we have asked some from the respondents on certain scales, and what we are trying to do is we are trying to standardize this data before we can use this further. And the WI here refers to the weights which is given, or the factor score coefficients for the I standardized value. So how are we going to find these factors is what I will be able to explain. So you will be able to notice here that once we have obtained in terms of the factors, that means once we have gone for this weighted average method, the principal component methodology that we are following, what it tries to do is it tries to come up with the values of WI, so that the first factor is able to explain the largest portion of the total variance. And once we have considered this, we will be able to consider a residual matrix. And the second principal factor is extracted from this residual matrix, so that you will be now able to understand that the first principal factor and the second principal factor which will be there are orthogonal in nature, and then thus we will be able to find that these are independent in nature. So how will we be able to get these factors is the first question. So if I am able to consider this data, okay, so first we have got how to calculate these factor scores. You will be able to notice that in the output, you will get something called as a component score coefficient matrix. Okay, and this is able to assign in terms of the weightages. Now, once I have got these weightages which are there, since I know that what is a factor, this is a weighted average. The first answers with respect to the 7 questions that I had asked, and these are the various responses by the first respondent. So if I can copy this data, okay, so if I copy this data which has been given, if I go to calculating factor scores, which if I delete these aspects, uh, what we want is we should be able to come up with a weighted average method, which is nothing but if I want to find out the value for the first factor, for the first respondent, I should be able to take the weight which is given by the component factor component matrix which is there, and then I should be able to take these standardized scores with respect to each and every response which has been given. So if this is the case, what I'll try to do is I'll try to consider here. This is the responses of the first respondent. And what I'll try to do is I'll try to transpose this data so that it is easier for us to look at. So if I go for transpose, okay, so we have got the data. Now what I want to do is I just want to find out the sum product function. Okay, so all I want to do is first and foremost, I need to convert this value which is there into standardized scores. So that is nothing but Z scores, xi minus mean divided by standard deviation. So equals to, this is the first xi, that is the response of the first respondent to the first question, minus you have got the mean, which I'll keep it constant, function f4, this divided by this need not be mean divided by the standard deviation. So if I go for it, this is the standardized score of for the first response which was given. And if I use the fill button, I would have got for rest other questions which are there. Okay, so once I have got it, I know that this is nothing but I need to find out the value that I have obtained here in SPSS. So in SPSS, you will be able to notice that I have got this minus 0.16 and I have got 0.68. These are nothing but these are the factor scores. Okay, so how did we actually arrive at these factor scores? And we know that this is nothing but in terms of the weighted average. So if I go for equals to, all I need to do is I need to consider the weight which has been given for the first factor. Okay, the first question which is there, and they are part of the first factor. So the weight into standardized value which is there. So this multiplied with the standardized value plus I should consider the second value into the standardized value for the second question response of the first respondent which is there. Now this I need to go on doing in the same way. So instead of that, what I can do is I can use the sum product function. So if I go for sum product, I will take the weights which has been given for the first factor, comma, I will be able to take the standardized value which is there for the first factor or for the first respondent which is there. And now if I go for enter, you will be able to notice that you have got the same value that you that is shown in SPSS also. So this is nothing but minus 0.16. The same thing, if I can go for sum product function, I'll take the first array, comma, I'll be able to take the standardized scores which are there and then enter. These are the values that we have got even in the SPSS also. So this is the values that we have got, 0.16 as well as 0.68. Now there are other methods also in which we can do the same analysis. Yes, you will be able to notice that you have got here, I can do in terms of the matrix multiplication also. In the matrix multiplication, you will be able to notice that you have got these weights and these weights, and this is nothing but you have got 7 rows and 1 column. So you have got a matrix with 7 rows and 1 column. And here you have got another matrix, which is nothing but all these standardized values which are there. Now, if I consider these matrix also, which is nothing but 1 row into 7 columns, and all I want is I want the resultant factor scores. So if I go for matrix multiplication of these two matrices, I will be able to get a matrix which is of 1 into 1. So what I can do is I can go for, in Excel, we'll do matrix multiplication. The first array is nothing but it is first 1 row and 7 columns, comma, I have got one and another one wherein I have got 7 rows with respect to 1 column. And then if I go for Control Shift Enter, you will be able to notice that you have got the factor scores. Okay, so this is how SPSS will be able to calculate the factor scores for the first respondent. Similarly, the second factor score will also be obtained as follows. Okay, so once we have obtained in terms of these factor scores which are there, what we are later on looking at is, so this is the component, and what we did was we are trying to multiply the values which are there in the component. These are nothing but the weightages which has been given. This we are trying to multiply with this standardized scores, wherein we are looking at xi minus mean divided by the standard deviations. Now, once we have obtained it, what we want to look at is we should be able to get in terms of the factor loadings. Okay, so here you will be able to notice that the factor loadings and the computation of the eigenvalues, because what you have to understand is you have gone for factor analysis and each factor is able to explain certain percentage of the variation. So how did we arrive at that percentage of the variations? So you have got here the correlation coefficient between the factor score, the correlation coefficient between the factor score which is there and the variables which are standardized is referred to as factor loadings, and the matrix which represents it is always referred to as a component matrix. So if we will be able to get a table in this way in the output, and this is always referred to as a component matrix, and you will be able to notice that how did we arrive at this minus 1.176 is nothing but we went for calculating the correlation coefficient between the factor scores as well as the standardized values. So if I go for the factor analysis, so if I look at what we have is these are the various respondents. We know how we got these values 0.16, 0.68, and similarly all the rest other values. Now what we want is in the second step, all we want is we should be able to get in terms of the factor loading. So how do we get in terms of the factor loadings is we have got in terms of the descriptive statistics here. All we have to do is we should be able to go for same thing. We need to find out the correlation that exists between the factor scores with respect to standardized value of these variables. So if I take xi minus the mean which is there, and this I'll keep it constant for the first column which is there, so function f4, and then this divided by the standard deviation, I'll keep this constant. Okay, so what we are able to now get is we are able to get these values which are there. These are the standardized variable or standardized values with respect to the response which has been given with respect to the first variable, and we have got the factor score. Now if I am able to find out the correlation that exists, the correlation coefficient, so if I go for equals to correlation between the standardized scores as well as comma, if I am looking at the factor score which is there, And if I try to do the same thing across all the variables which are there, we will be able to arrive at what is referred to as these factor loadings. Okay, so once we have got in terms of the component matrix which is there, what we'll do is we will try to use these component matrix, or in terms of the factor loadings which is there, for calculating the eigenvalue. So for this, what we'll be able to do is to decide on the number of factors. We'll be able to go for Kaiser-Gutmann methodology. And here what we try to do is, you will be able to notice that depending upon how many variables that you have considered, okay, what we understand here is each and every variable that we have considered, it is able to explain a certain percentage of the variance. And what we assume here is each and every variable will have an eigenvalue of 1. And all we are trying to do is we are trying to find out the eigenvalue, and any factor which is having an eigenvalue of more than 1, we will be able to consider that as one of the factors. So if this is the case, we have got this component matrix. If you are able to find the square of each and every value which is here with respect to the first factor, that is nothing but the eigenvalue for the first one. So how did we get this 2.054? Yes, if we go for here, factor loadings, you will be able to notice that we have got here the component matrix, and all we have to do is we have to find out the eigenvalues. So how will we be able to find out the eigenvalues? Is nothing but the sum square function. So if I'm going for the square of each and every value which is there, so instead of doing it, what I can do is I can go with the shortcut. I can go with the sum square function, and then I can consider all the values here. So this is the eigenvalue, sum square. This is the eigenvalue for the first factor as well as in terms of the second factor. Now, once we have got in terms of the eigenvalue, what I need to know is what percentage of the variation has been explained, because all I'm trying to do, why I'm trying to go for factor analysis is I want to reduce the number of variables, but by doing so, I want to ensure that I capture majority of the variation. Okay, so I would never like to compromise on that. So if I have got factor 1 as well as in terms of factor 2, I would like to know how what is the percentage of the variations. So if I assume that each variable is equivalent to or is equivalent to one eigenvalue, all I'm trying to do is, since there are 7 variables which are there, if I'm able to divide this eigenvalue by the number of variables that I have considered, I will be able to get the percentage of variance. Okay, so if I consider this, if I consider equals to 2.05 divided by 7, you will be able to notice that 29% of the variation, and this is the table that we had got. So 29% of the variation is explained by the first factor. And similarly, if I go for 1.55 divided by 7, you will be able to notice that another 22% of the variation is explained by the second factor. So overall, put together, you will be able to notice that the cumulative percentage, both the variables together, is able to explain 51% of the variation. So you have got, so now you know that how we have got these values which are there. And once we have looked at the percentage of the variation and how many factors should we be able to consider in our study, then what we'll be able to do is we will be able to look at what we want is, yes, I now know that I should be able to select 2 factors, and these 2 factors are able to explain around 50% of the variation. Now, what is important is which variables will be part of these factors, okay, and which variables should be part of these factors. And once I come to know that, I can use this for further analysis. So what I'll be, since we went for what is called as the Varimax method, and what we have is the initial factors that we have obtained are difficult for us to interpret, and thus we will be able to go for the rotation, and Varimax rotation method is what is followed. And what we generally follow according to the literature review is, if we have to select the variables to be part of a factor, we will be able to go for some cutoff point, and which is subjective, but we have to have a very strong evidence from the literature review also. And whichever factors, if I assume here that any factor which is, any variable which is there is greater than 0.5, those are the variables which will be part of the first factor. So if this is the case, what we try to look at is, we try to look at, I'll just show the output. So what we try to look at is, we try to look at the rotated component matrix, and depending upon what the cutoff level that we have considered, any value which is greater than 0.5, these are the variables which will be these are the variables which we will be able to consider to be part of our first factor. And similarly, any variable which is greater than 0.5 are the variables which will be part of the second factor. Now, once we have identified based upon the variables, we will be going for the commonality. Now, commonality indicates how much of each variable is accounted for by the underlying factor. So because what we want is, if I take the first variable where I had asked on risk averseness, the second one was on tax rebate, everything else. So what percentage of each variable is accounted for? So if that is the case, what we'll be able to do is, the first variable, risk averseness, because here we had got the component matrix which is there, and you will be able to notice what we did was, in order to find out the eigenvalue, we went column wise. We took all the square of these values. So if I am able to look at row wise and then say the square of these first two columns of the first row, that is risk averseness, this is able to give us what is called as the commonality matrix. So if I consider the negative 0.176 square plus 0.753 square, I will be able to understand that 59.8% of the variation with respect to the first variable is explained by the first two factors. And this also becomes very, very critical, and this is often ignored also in majority of the analysis. So it is always important that you also include this. And what is so important about coming up with the factor analysis is, when we go for regression based methods, so the multicollinearity problem is one of the key aspects which come into picture. And due to this aspect, you will be able to notice this will have impact on the standard errors, everything else. And in order to avoid it, what we want is, we want to consider the variables which are do not have the problem of multicollinearity. So if I look at these two factors which have been obtained, and if I go to analyze, if I go to correlation, bivariate, and if I'm able to look at these two factors that we have obtained, and then if I look at in terms of the correlation matrix, you will be able to notice that these are completely independent of each other. Okay, so that is what we want to use, or we want to go ahead before. And what is the end result of factor analysis is this, that when we go for these factors will be statistically independent, and will not have the problems of multicollinearity when we go for further research also. So if I am going for the rotation of the factors, if depending upon the cutoff, so if according to the research, if I consider that the cutoff is 0.7, you will be able to notice that there are some variables which are there. For example, variable on credibility and easy accessibility, which is X6 as well as X7. These are part of the first factor. And similarly, the variable on risk averseness and insurance cover are the two variables which are part of the second factor. Now, since these are the underlying constructs, okay, since these are the underlying constructs, what I'm trying to do is when we want to build in terms of the models, everything else, what we are trying to do is we are just going for a exploratory factor analysis where we are trying to explore and say which are the variables which are part of the factors, and then you will be able to notice that depending upon what these variables which are part of these factors, you will be able to label them. So since we are talking about credibility and easy accessibility, we will be able to name the first factor as the perceived value. When they go for investment, they always look at the perceived value, and then we will be able to look at the security factor, because when we talk about the main objectives of investment, we always talk about minimizing the risk, maximizing the risk, return, and then we are talking about the liquidity. We are talking about in terms of ensuring that there is hedge against inflation. So we are mainly looking at variable on risk averseness as well as insurance cover. So now if we are able to go back to ggplot, and then depending upon what are the variables which are part of the factor, if I am able to come up with the facets, if I am able to come up with the scatter plot, or if I am able to come up with multiple plots which are there, wherein I can have the averseness, risk averseness, and I can have another indicator which is nothing but the insurance cover. And then if I'm able to look it across the various years, I will be able to justify, I will be able to further elaborate in my research as to factor 1 as well as the factor 2 which has been identified are critically important. And then this, I will be able to use these two factors, perceived value as well as security factor, in my classification based method. So if I want to classify a respondent as being, for example, risk averse or not, I can consider these two factors which are there, and then go ahead in terms of differentiating. So if I want to say, who are the investors who would like to go for investing in stocks? Okay, so yes or no, since it is going to be in terms of a discrete data, I can go for classification based method wherein I can do this research wherein I have got these factors. Now I can use these factors into classification based method, and then I can say what is the probability of me finding a respondent who would be able to invest in stocks. So logistic regression, discriminant analysis, we will be able to go ahead with the analysis that we have got there, and then we will be able to use the interpretations of these factor analysis, and then use it in various decision making purposes also. And thus when we look at the applications part, and this is what I thought that I will be able to cover tomorrow, is if I have got the same results which are there, if I use the same results further, either in terms of the multiple regression, okay, or if I want to consider this as part of the classification based method, or if I would like to do the association based learning or recommendation system. Okay, so if I want to come up with a recommendation system wherein I can come up with these factors or the variables, and depending upon these variables which are there, is it possible for me to look at, or when I collect the responses of a new respondent, is it possible for me to identify whether this person who is there is going to have more chances of investing in the stocks, or whether he is more risk averse and would like to invest mainly into fixed deposits, or he would like to go for mutual funds. Within mutual funds, who are the one who will go for sector specific investment or equity based investments, or who will go for balanced funds, who will go for income based funds. It is possible for me to make recommender based systems based upon the kind of results that I have got. So what I would like to say is, when we have collected a lot of data, what is very, very important is when you when you go for a collection of responses also, you have to ensure that the data that you have collected is appropriately decided. So you should be able to do some pilot testing in the beginning, and then you should be able to decide what number of questions will be nominal based, because in the nominal based data, all I can do is I can come up with the frequency, I can come up with the percentage, not more than that. I can say how many male were there, how many female were there. I cannot use this for further analysis, though there are some non-parametric methods which are there. But what we try to do is we try to have less number of questions which are nominal based, but we would like to collect more information which is there on the scale based data, since we are understanding the behavior or perception of the respondents and then going further. So if we are able to collect this data, it is possible for us to first go for some unsupervised learning methods, either go for cluster analysis or either go for factor analysis. Once you have identified the various important factors, and these factors, since they are able to explain maximum percentage of the variation, we can use this for further analysis. Okay, so this is what I wanted to complete also today. So if there are any questions, you can ask. I can put the same thing in the chat box. So because if I go with the cluster analysis, everything else, that will take much time. But at least if you want, if we are going for the another supervised, unsupervised learning method also, wherein if all I have done is I have tried to reduce the dimensions across the various columns which are there. But if I want to reduce the dimensions across the rows, wherein I'm taking the records which are there, or I'm taking the cases which are there, and if I want to group together these cases in such a way that they are mutually exclusive, there exist significant differences among the groups which are there, but there exists a lot of similarity within the groups, we will be able to go for cluster analysis also. So wherein what we will be able to do is we will be able to go for classify, and then we will be able to go for cluster analysis. And depending upon whether you want SPSS to itself decide how many clusters will be there, or you want to decide how many clusters, you either go with HAC, hierarchical clustering method, or you will be able to choose in terms of the k-means clustering method. So if I assume that I will be able to go with the number of clusters that I want to come up with is just 2 clusters, or I would like to come up with just 3 clusters which are there. And if I take in terms of the various variables which are here, so I'm not going in terms of the theory part here. Save the cluster membership distance, and here when we go for cluster measures, the distance measures plays a very, very important role. So so we will be what we will be able to get is, it is possible for us to get the data. Okay, so it is possible for us to group together the data also into certain clusters. So here you will be able to notice that the number of cases in each cluster which is there, it is able to, since we explicitly mentioned that I want to have 3 clusters, and which are the respondents who will be able to belong to the each cluster. Roughly, what we are able to do is we are able to use the cluster analysis, and we are able to group together the cases, or in terms of the respondent, into various clusters. And now if we identify that the cluster 1 is belonging to those respondents who spend a lot of time into research, and they are very, very risk takers, you can capture the data only with respect to them, go ahead with the factor analysis, and then conduct the regression as well as classification based methods. So what we are trying to do is we are trying to go with the cluster analysis, because I believe that when I talk about investors, depending upon what kind of investors they are, I would be able to build some recommendation systems only specifically with respect to them. So if that is the case, for me, cluster analysis becomes very, very important rather than factor analysis. So what I will do is first I'll go for cluster analysis. I'll divide the data into various clusters. So first cluster, I have got 3 clusters here. The first cluster, 38 respondents are there. And if I say that the first cluster belongs to those people who are risk takers and would like to invest in, they would have more research taking capability. At the same time, they would have more money to spend also. So if this is the case, I can take them separately. Cluster 1, I will do factor analysis on it. Once I get in terms of the factors, these factors which are there can further be used into regression as well as classification based methods, or in terms of the recommendation systems, or if I have got transaction data set which is there. And if I know that they have what kind of investments that they have made. First they had gone for fixed deposit, then they have gone for example PPF, then they have gone for mutual funds, then they have gone for stocks. So if I have in terms of this kind of data also, it is possible for me to use some association rules based methods which is there, and build some recommendation systems based upon it. So these are the various possibilities which are there. So here, what I wanted to concentrate today is when it comes to multivariate analytic techniques, what we tend to do is first, when I have collected all the responses, everything else, we would like to do some descriptive frequency, everything else. We would like to look at these variables and try to understand these variables. But what is missing is when you go for frequency or descriptive statistics, you are just saying how many male are there, how many female are there. You are not saying among male, considering the risk averseness, how many have look or across the years, whether the risk averseness has changed with respect to gender. We are not looking at it. We are looking at each question as a silo, and then we are writing the interpretation. Instead of that, what we should be able to do is we should be able to take into consideration several variables, and then we should be able to go for interpretation. So that will be able to add more value, and that is where these R programming, Python programming, visualization methods are coming into picture, wherein they are able to give us much more better insights rather than these customized softwares which are there, such as in terms of SPSS, or going for Excel also, which is very, very limited. So what I would recommend is whenever you go for any research or writing research papers also, what we mainly concentrate now on is do not just go for frequencies or descriptive statistics. What we want is we want more insights with respect to the variables that we have considered. So if you have collected the responses very carefully and keeping in mind that these responses can be used further in various analysis, that is how one should be able to proceed further. So literature review plays a very important role. You are backed by the literature, you have a model, depending upon the model, you come up with a structured questionnaire, you corrections during pilot testing, and then you will be able to use this data and build some various models. So before we jump into before we jump into various multivariate analytic techniques which are there, considering that these are dependency based techniques, we should be able to understand these aspects and move further. Okay, so if there are any questions, please put that in the chat box, or otherwise we can wrap up for the day 2 of the session on multivariate analysis and research. Any questions? And I understand the limitation. I know that these are the subjects, and we have several FTPs where they conduct this for 5 days or 6 days. But overall, the crux of the overall research is to understand how would you go about doing the analysis. So, any questions? Any questions? So, if there are no questions, then we'll be able to meet tomorrow. So, thank you all from Department of Management Studies, Darren Sagar College of Engineering. So, thank you all. Thank you.